I'll be talking about dark matter. Why does it matter, you say? I say you'll see.
Vera Rubins, an American astronomer, was the first one to draw attention to the possible dark matter, or back in the 1970s, missing matter, basing her research on 2 decades of hard work.
Well, you want to know how we knew if there was missing mass or not? Huh, that's a story for you. It's a question of gravity. When we looked at other galaxies, the stars, and their orbits at the speed they orbit at, we were just like, they're moving so quickly that they should be moving. These galaxies are much more massive than the light that they emit. Seriously, where did all the mass go? It's just missing mass. Is it like just some dark matter? At least we figured out like what 90% of the universe is filled with, that it outweighs the mass of material that we know of, 1 to 10. So we still don't know what form dark matter takes, but we have classified them as 2 objects as we speculate at what they might be. We call them machos and wimps.
Did somebody say macho? Are you looking for me?
1, 2, 3.
Oh, I think I'm gonna go lift some weights.
Here's some weights. That one's too heavy. I'll try this. 1, 2.
Wrong! WIMPs stand for weakly interacting massive particles. They're hypothetical. We have not detected them. They're subatomic particles that have no electric charge. So, because we haven't been able to detect WIMPs, they could be moving right through your body right now with virtually no interaction. So if WIMPs do exist and do contribute to the missing mass that we have detected, there would have to be an enormous amount of them because they're subatomic particles and yet outweigh normal matter by such a large factor. So patience is required because only 1 WIMP in a million will typically hit an atom so that scientists can detect them. Well, so far, no WIMPs have been detected. The search goes on. Machos, on the other hand, or compacting halo objects, astronomical bodies that emit little or no light. So candidates for these could be supermassive black holes, brown dwarfs, or free-floating planets that are not captured in gravity around a star. The most promising way of detection is to look for gravitational lensing events. Einstein's theory of relativity shows how mass can bend rays of light, just like a lens, hence the name, gravitational lensing. So, an example of this would be a faraway galaxy being distorted by gravity in a foreground galaxy. So it comes out all bent and weird. It is known and many examples of it have been found. Many macho candidates have been detected between about the size of Jupiter and the Sun. For the first time, scientists have been able to map the distribution of dark matter in our universe. Thanks for watching this Astro Abbey, where we talked about dark matter. Remember, keep looking up.